Okay, now that we've introduced momentum, let's get into a little bit more detail regarding the vector nature of them. So we know that momentum is mass times velocity. And since velocity can be written in components, momentum can also be written in components. So we can have our momentum in the x direction would be our mass times our velocity in the x direction. And momentum in the y direction would be mass times velocity in the y direction. Similarly, we could have momentum in the z direction if we did 3 dimensions, and that would be equal to mass times velocity in the z direction. Okay, so all it is there, like our x component momentum is mass times the x component velocity. So all we really need to do is break the velocity into components and then multiply it by the mass, and we've broken the momentum into components. So let's do just a couple quick exercises how we can use this and see how it's very similar to things we've done previously. Let's say we have here a 5, actually, let's say we have an 8 kilogram mass, and it is moving off at 5 meters per second at an angle of, we'll say, 20 degrees above the horizontal. What is its momentum? Well, we could say its momentum is 40 kilogram meters per second at 20 degrees. That would be one way to describe it, but we can also find its components. So the momentum in the x direction is just the mass times the velocity in the x direction, which is the mass times the cosine theta, as long as theta is measured in standard position. So then, we have to make sure that we are giving a coordinate system here. And so momentum in the x direction in this case would be 5 times 8 times the cosine of 20 kilogram meters per second. Similarly, the momentum in the y direction would be equal to 5 times 8 times the sine of 20 kilogram meters per second. Okay, so we can break into components just exactly the way we've broken everything else into components, noting that really it's just the velocity is broken into components and then multiplied by the mass. Or really we had a total momentum of 40, and then this is the x component, 40, and this is the y component. We could also say here, say we have a different exercise. Maybe we have 5 kilograms that's like this, and it's moving off at some velocity like this, v. We don't know what this is, and we don't know what angle it's moving off at. So we don't know the velocity or the angle theta, but you are told that the x momentum is equal to 30 kilogram meters per second, and that the y momentum is equal to 17.5 kilogram meters per second. Then we use the same strategy that we used previously. If you're given x and y components, we can find the total momentum and the angle. So the momentum really, it makes a triangle, just like previously. We have, this is our momentum vector, like this. So this is the momentum in the x, and this is the momentum in the y. This is our angle theta. So then we can find theta the same way we did when back in the vector chapter. The angle theta is equal to the arctan of the opposite over the adjacent. So this would be the y, as long as theta is in standard position. The y component divided by the x component. And so this is the arctan of, we have 17.5 divided by 30, and our angle theta ends up being equal to 30.25 degrees. We can also find the magnitude. Find the magnitude the same exact way we did before. Actually, we wanted to find the velocity, but we can find the magnitude of the momentum same way that we find the magnitude of acceleration, velocity, displacement, etc. This is just from Pythagorean theorem, all solving this triangle here. It is going to be equal to the square root of the sum of the squares of its components. So this is the square root of the x component was 30 kilogram meters per second. The y was 17.5 kilogram meters per second. So we have, this is 30 squared plus 17.5 squared. And so the magnitude of the momentum is 34.73 kilogram meters per second. And since momentum is mass times velocity, mass is a scalar quantity, so we don't have to deal with its magnitude anyway. Then we have the magnitude of momentum must be the mass times the magnitude of the velocity. So then this means that we have 34.73 is equal to, the mass was 5 kilograms. So this is 5 times the magnitude of the velocity. And then solving for the magnitude of the velocity, we have this is equal to 6.946 meters per second. So, given the components, we solve it just the same way that we did back in the vectors videos. The angle in standard position would be the arctan of the y component over the x component, and the magnitude of the momentum is just from Pythagorean theorem here. The only thing is, if we were asked to find the velocity, we would then need to divide this momentum by the mass, as we did back here to find our velocity. So momentum can be broken into x and y components as well. It's just mass times their x and y components of velocity.